Assalamualaikum warahmatullahi wabarakatuh. We are from group 2. We will present about experiment 6, torsion of bar. We are from SETG 3751. Introduction for this experiment. The torsion bar is a flexible spring that can be moved around its axis by twisting. The torsion bars are designed based on the torque amount used during the torsion of the springs, the torsion angle, the overall size of the torsion bar, and its material. The torque is the moment that tends to produce a turning point. The most common place to find torsion bars is a shaft that used to transmit power from the blades of a wind turbine for the generator. It can be hollow or solid material and also in manufacturing machine or other precious equipment. The flexibility of the spring is the main reason the torsion bar is used. Objective for torsion bar experiment: to investigate the relationship between torque and the angle of twist of the rod and to determine the modulus of rigidity of materials. Scope from the objective: to discover the difference of material of rods used, which are aluminium alloy rod, nylon rod, and steel rod. To study the different length of rotation scale and pointer from the fixed clamp, which are 240 mm and 400 mm. And third, to study the range of weight for the loads applied within 1 Newton to 20 Newton because each rod have their limitation. Theory working principle. This is the formula that we use for this experiment, which is shear stress, shear strain, angle of twist, polar moment of inertia. Angle of twist is to determine a material shear modulus experimentally, while polar moment of inertia, the resistance of a cross-section to torsional deformation due to the shape of the cross-section. And this is the formula for solid rod. J equal to pi over 2 multiply with C power of 4. When the bar is subjected to torsion, it can be imagined that the bar is made up of multiple individual discs that rotate relative to one another when the torque is being applied. Therefore, the distribution of shear strains that were created by torsion within the circular shaft can be determined. Furthermore, this will show that shearing strains varies linearly with the distance from the center of the cross-section. The change in the angles created by both sides of the shaft can be measured to obtain shear stress by using the following formula: Y equal to rho multiple with P divided by L, which is Y is shearing strain, rho is length from the center to any point in the circle of the shaft, P is the angle of twist, and L equal to length of shaft. This is the theoretical value for the modulus of rigidity for aluminum alloy rod, nylon rod, and steel rod. This is the experimental setup for the torsion of bar experiment.
So now I will be presenting about the methodology. First, set up all the apparatus. Second, the clamp is in the correct position in one turn. Third, the nylon rod clamp in tightly. Third, the nylon rod clamp in tightly. Third, the nylon rod clamp in tightly. Next, measure the appropriate distance such as 240 mm to 400 mm from the clamp. Next, the pointer was fixed at 0 before start reach the data. Next, put a load on the hanger starting from 1 Newton up to 5 Newton. And lastly, repeat the same steps by replacing with iron rod and aluminum rod, but change the load to 5 Newton until 20 Newton.
Okay, let's see all the result that we get from this experiment. Okay, the data that we use in this experiment is torsion head effective diameter D is equal to 77.79 millimeter. Next, torsion head effective radius R is equal to 38.88 millimeter. Conversion of 1 degree to radian is equal to 0.017453. Okay, table 1 is the data for aluminum alloy rod. For the calculation of torque, we use the formula torque equal to hanger load multiply with torsion head effective radius. For example, we multiply 5 with 38.88 and then we get the torque is equal to 194.4 Newton millimeter. Okay, for the angle of twist of rod in radian, we convert the degree to radian. For example, 0.5 multiply with 0.017453 and then we get angle of twist in radian is equal to 0.0087 radian. Next, table 2 is the data for nylon rod and the table 3 is the data for steel rod. We use the same formula for the torque, which is hanger load multiplied with 38.88 and then we get the value for the torque. Same with angle of twist of rod in radian. We multiply the degree with 0.017453 and then we get the angle of twist of rod in radian. Okay, next we continue with the discussion part.
So this is the calculation for aluminum alloy rod. So this is the calculation that we do for this experiment. So the G average that we get is 28,942.95 Newton over millimeter square, and the, this is the graph, the angle of twist of rod gradient against torque for aluminum alloy rod. So next, this is the calculation for nylon rod. So the calculation that we do and the G average that we get is 2301.31 Newton over millimeter square. So this is a graph of angle of twist of rod against torque for nylon rod. So this is the calculation for steel rod and the G average that we get is 69,528.95 Newton per millimeter square, and this is the graph of angle of twist of rod against torque for steel rod.
1. To what extent does the experiment verify the torque or twist formula based on the graph plot? Based on the three graphs that we has been plot, it show linear increasing trends where the torque is directly proportional to the angle of twist of the rod. The greater the torque applied to the rod, the greater the angle of twist of the rod would be. Next, the graph show that the length of the rod between fixed clamp and rotational scale also can affect the angle of twist of the rod. The greater of the length of the rod between fixed clamp and rotational scale, the greater the angle of the rod will produce. The graph also show that the type of material used affect the angle of twisting and it exhibit their purely elastic behavior. Therefore, the modulus of rigidity G in inversely proportional to the angle of twist as theta, which is the angle of twist in radian, equal to TL over JG. Second, comparison between three different types of rod with different length of rotation scale and pointer from the fixed clamp. When the length of the fixed clamp and the rotational scale increase, the angle of twist of the rod also will be increased. Based on the result that we get from this experiment, we can see that the angle of twist of the rod over 400 mm is larger than the angle of twist of the rod over 240 millimeter. Then, we also can conclude that the angle of twist of the rod produced on nylon rod is the largest, followed by the aluminium alloy and steel, despite the load applied on the nylon rod is lighter than others. It is because every material of the rod have their own limitation and it exhibit their purely elastic behavior. For comparison, the aluminium alloy rod is greater than steel rod, while it is weaker than nylon rod. Third, based on your finding, explain the relationship between the modulus of rigidity of material with the parameters such as type of material for the rod, length of the rod, the shape of the rod, and polar moment of inertia. Okay, the formula for percentage error is experimental value minus with theoretical value divided by theoretical value multiplied by 100. Okay, percentage error for aluminum alloy rod, we get 11.32%, while the percentage error for the nylon rod, we get 41.49%. Next, the percentage error for steel rod is equal to 7.29%. Okay, based on the calculation on the percentage error on each material of rod, there are slightly different and bigger difference between the experimental value and the theoretical value. The difference of experimental value with the theoretical value is due to some errors when we are conducting the experiment. We found that the results from the experiment are true with the modulus of rigidity formula. Here, we can see that the steel rod have the highest modulus of rigidity, followed by the aluminum alloy rod and nylon rod. It is because steel is a metal alloy composed of iron, carbon, and few other elements, while aluminum alloy is a soft metal with a silvery grey color. Nylon are a type of polyamide which is synthetic.
So next, this is the safety procedures. First is the rotation scale must be set to 0 millimeters before and after use to avoid any possible errors. Second, the eye must be perpendicular to the reading of the rotation scale to avoid the zero error. Third, make sure the digital caliper is set to 0 millimeter before using it. Fourth, wear a lab coat and closed shoes when doing any experiment to avoid any accident in labs. And finally, hair in neat condition for male and non-Muslim students to avoid injury.
Okay, next we continue with the conclusion part. Okay, for the conclusion. For conclusion, the objective of the experiment is to investigate the relationship between torque T and the angle of twist of the rod and to determine the modulus of rigidity G of material. We use three different types of rod, which are aluminum alloy rod, nylon rod, and steel rod. From the graph, we can see that the angle of twist of the rod is directly proportional to the torque T and the length of the rod between the fixed clamp and the rotational scale L, but inversely proportional to the modulus of rigidity G. From the experiment, steel rod has the highest modulus of rigidity, followed by aluminum alloy rod and nylon rod.
Next is the reference. So this is all the reference we use in this experiment. And I think that's all from us. Thank you.